morning. My name is Shannon Whiting. I am an advertising major and a double minor in digital technology and culture and environmental science at Washington State University in Pullman. I was part of this internship under Dr. Lovecoat, and the objective of my project was to create an informational handout to give to people who come to the demo farm. The format of this was a fold-out newsletter style with a front page, 2 middle pages, and a back page. So my first page just gives some background information about the farm. The demo farm was created to help growers make easier, faster decisions regarding things like irrigation, cooling, and labor hiring. It hopes to support agriculture by introducing artificial intelligence into ag settings, giving students hands-on experience with how sensors interpret and process information, and to serve as an example for growers, field workers, educators, and technology providers on how artificial intelligence can be beneficial. So since these groups of people are the ones that will be spending time in the demo farm, they became my intended audience. My second page goes over some of the sensors that we have in the demo farm. So to gain enough knowledge about these, I started with basic information that told me what the sensor measures. It took a little bit of research for me to understand that enough to put it into simpler terms, but it took a lot more so when I was finding out how the sensors essentially do what they need to do. Most of the information I found about that contained large scientific terms that I wasn't necessarily familiar with. So turning that into something relatively easy to understand took a little bit more effort through consulting others, researching definitions and explanations, and then drafting, redrafting all of my edits. So to show you a little bit of that editing process, I'm using the information I found about the TERRAS 21 as an example. So the 3 things that I thought were the most important to get across from the raw definition were the material importance, why it had to have a known pore size, what hydraulic equilibrium is and why it's important, and what the second law of thermodynamics states. I discovered that ceramic is used because it has a known absorption rate. Hydraulic equilibrium is reached when the sensor neither absorbs nor discards any water, and the second law of thermodynamics describes the process of reaching equilibrium. The other soil sensors we have besides the TERRAS 21 are the TERRAS 11, the TERRAS 12, and the EnviroPro. The TERRAS 11 measures soil temperature and moisture. The TERRAS 12 does this as well, in addition to measuring electrical conductivity. The EnviroPro is similar to the others. It measures soil moisture and temperature. It's multi-layered, so it senses in multiple depths using a single body, which is how it differs from the TERRAS sensors. The other 2 forms of artificial intelligence that we have in the demo farm are canopy sensors and a network. Our Apogee infrared sensor measures canopy temperature using an infrared camera. Anything that's warmer than 0 degrees gives off an infrared wave, and the sensor interprets the waves and knows the corresponding temperatures. And our data logger collects data from the sensors and uploads it to the cloud using cellular network. My third page describes some of the ag projects that will take place in the demo farm. And through these projects, the demo farm will support the need for process models, experimentation, and the use of automation in place of or in collaboration with human laborers. So farm operations projects focus on the use of artificial intelligence for common farming challenges such as frost mitigation, deficit irrigation, and harvest management. Artificial intelligence can support frost mitigation by finding out what the effects of repeated frost on crops could entail, cost of mitigation, and real-time decision-making regarding things like weather forecast uncertainty. If you don't have a weather station in your field, the temperature reading will not be 100% accurate, so having sensors there to give you a site-specific reading will help you make those real-time decisions to potentially take action to warm up your crops if needed. Deficit irrigation research could use artificial intelligence to sense soil moisture, weather data, and crop stress with sensors that are similar to the ones in the demo farm already. And harvest management could be supported by sensors that are able to tell the maturity of the fruit so growers can plan ahead and hire labor accordingly in order to avoid harvesting at non-optimal times. Labor intelligence projects focus on what artificial intelligence can do in regards to labor work like mechanical harvesting, flower thinning, and intelligent pruning. Mechanical harvesting is usually done by tree shaking, so discovering the correct parameters for this process based on tree age and variety, and then creating a manual through artificial intelligence will make this process much simpler and easier accessible to those without a lot of experience. Some solutions to flower thinning challenges using artificial intelligence would be to use robot vision to detect and localize blossoms, or to use it in collaboration with humans and have the artificial intelligence pick easily accessible blossoms and then have the human go through afterwards to thin the ones that are more difficult to reach. And artificial intelligence can help with intelligent pruning by locating good spots to prune to keep the tree in good health in order to produce high-quality fruit. So for my 4th and final page, I decided to add some information about a few things that I worked pretty closely with this summer. The irrigated agriculture Research Extension Center is an extension of WSU that supports interdisciplinary decision-making and serves the research needs in the surrounding area. The Center for Precision and Automated Agricultural Systems uses the world's most recent technology in ways that benefit Washington State. It focuses on automated agriculture, and it's where my internship took place. The Ag-Aid internship program is a way of creating and supporting relationships between agriculture and artificial intelligence. And finally, AgWeatherNet is a collection of weather stations across the state that provide information about key weather parameters such as air temperature, wind speed, rainfall, and other things like that. So that was my project. Thank you so much for your time.